Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Assalamu alaikum to everyone and hello to everyone. I hope you all are doing well and keeping safe under these post-pandemic scenarios. Just a brief introduction about myself. My name is Muhammad Adnan Javed Pirzada. I have received MBA in Finance from IIBM Karachi in 2020 and BSc in Chemical Engineering from NFC IIT Multan in 2003. Currently, I'm working as General Manager in Dewan Distillery. I have 16 years of experience in the field of process engineering, during which I have been able to have hands-on experience of installation and commissioning of ethyl alcohol manufacturing unit and biogas manufacturing unit in collaboration with French engineers. Troubleshooting and modifications in steam boilers, steam turbines has been an important area of my field experience. I have received on-the-job training for S.A.P and participated in performance management workshop in Singapore from internationally acclaimed trader Mr. Monty Sacher. My professional interest focuses on adopting latest technological advancements in distillery operations and overall plant management. Furthermore, my vision is to inspire young leaders to explore new horizons in their professional lives. The topic of my presentation is Potential of Ethyl Alcohol Manufacturing for Professional Engineers and Analytical Experts in Pakistan and its significance in Pakistan's economy and global economy. The outline of the presentation will be, I will give a brief intro about my company, then I will start about brief about the process, starting from feedstock, which is sugarcane molasses. Then there will be a brief intro about the technological scheme, how ethanol is being produced from molasses. Then I will explain a bit about the potential for technical and analytical experts in this field. Then I will explain Pakistan ethanol export scenario and global ethanol scenario. Dewan Distillery plant is situated in Sajawal on Thattabadeen Highway. Dewan Distillery was commissioned under the supervision of French engineers in November 2004 with an installed capacity of 125,000 liters per day of ethyl alcohol using sugarcane molasses as a raw material. The plant produces premium quality ethanol with state-of-the-art technology of Engr in Paris, France. The plant is controlled by Rockwell Plant Pax DCS control system. Dewan Ethanol has per annum installed capacity to produce 33,000 metric ton of ethanol. We have three different grades of ethyl alcohol: anhydrous alcohol, which is 99% pure, extra neutral alcohol, which is 96.6% pure, B grade alcohol, which is 94.5% pure. Dewan has multiple certifications. We have FSSC 22000, ISO 9001 2015. We have kosher certification as well as kosher for Passover certification. Dewan has also participated in Kosher Fest in year 2019 in USA in New Jersey, and Dewan was first company from Pakistan to have attended this event, this global event. Now I'll explain how the ethanol is being made. Sugar cane is the basic crop for the production of sugar and molasses. The sugarcane yield for the year 2015-16 was 57.8 tons per hectare, and it has now increased up to 64.3 tons per hectare. There is still a huge potential for improvement in enhancing sugarcane yield per hectare as well as the quality of sugarcane for enhanced sugar content. If we talk about historical data of last 5 years, you can see that there has been a consistent cultivation of this crop, and in the right column we can see that there is a gradual improvement in yield in terms of tons per hectare, and also we can see here that the year 2017-18 was the year for the highest production and highest cultivation and production. Molasses is a viscous product resulting as a byproduct from refining sugar cane into sugar crystal. Molasses varies by amount of sugar content, method of extraction, and age of plant. Sugar cane is harvested from the fields, stripped off its leaves, and then sent to sugar mill for crushing. The juice is extracted by cutting and crushing in various steps. The juice is then boiled, filtered, and concentrated. Then, after various process steps, sugar crystal is produced. The remaining liquid after the crystallization is called final molasses. Before the year 2010, 90% of the molasses was exported from Pakistan. Later, Pakistan installed distilleries for the production of ethanol to move into a value-added product. Today, all molasses is being used as a feedstock in Pakistan for producing ethanol. Total production of molasses in last year was 2.25 million metric ton. This year, there would be an increase of 15% over the last year and expected to have a production of 2.58 million metric ton. Again, if we see the historical data of molasses production of last 5 years, we can see that year 2017-18 was the year of highest production, and there has been a decline in the production. This also shows that there is room for improvement in molasses production as well as subsequent production of ethanol. Now we talk about the schematic for ethanol production. Molasses is a thick viscous liquid. It has a density of 1.4 to 1.45. So in the first step, it is diluted with water. Then this diluted mass is passed through inoculum. Then it is sent to the fermentation step, and after the completion of fermentation, where majority of the sugar content being fed is converted into ethyl alcohol and CO2 is liberated as a byproduct. Then this fermented mash is sent to the distillation section, where we have a process involving under vacuum distillation as well as under pressure distillation, and after passing through multiple steps, we get the 3 different grades of alcohol as a product, which are anhydrous, rectified, and B grade. If we talk about the reaction chemistry, basically the sugar molecule present in the molasses is converted into ethanol and CO2 in the presence of yeast. The reaction is the reaction completes in 2 steps. The first step is termed as hydrolysis, where the sucrose molecule is hydrated with water, and then in the next step, in the presence of yeast, this molecule is converted into ethanol and carbon dioxide is liberated. This reaction is called as glycolysis, where the glucose is being converted into CO2 and ethanol. This is the yeast is the core reason for this reaction. The yeast which is being used here is Saccharomyces cerevisiae, which is a very common and it is being used since ancient times. The function of this yeast is to convert the glucose molecule into ethanol and CO2 by excreting enzymes. This is achieved by propagating this yeast into an inoculum, where we feed nutrition, air, to maintain and develop a certain cell population. Yeast has following nutritional requirements. It needs water, carbon source, oxygen, nitrogen source, vitamins, and minerals. It is a very hygiene sensitive process, and yeast remain under a lot of external stresses, some of which are temperature, sodium sulfide, formation of lactic acid and acetic acid, effect of pH, fusel volatilities, high ethanol percentages, and CIP chemicals. The main and the very core step in the process of this manufacturing of ethyl alcohol has been to maintain a healthy, hygienic, and active yeast in the pre-fermentation step and for the fermentation step. If I give a general brief about the process of manufacturing process of fermentation, molasses is diluted with water and is partly sent to the pre-fermentation tanks for the development of yeast culture in the presence of oxygen and nutrients. This developed culture is then fed to fermentation tanks, and then diluted molasses is fed in it for the production of ethyl alcohol. The reaction takes approximately 40 hours to complete, and all the sugar content is converted into ethyl alcohol and CO2 leaves the tank from the top. A general schematic for a pre-fermenter is that a tank is connected with a circulation pump and a heat exchanger. The purpose of circulation pump is to have maximum mixing of the internal media, and as it is an exothermic reaction, so we have to maintain a temperature for which we use heat exchangers. The same schematic is involved in a fermenter tank, where a tank is connected with a circulation pump and a heat exchanger. Pump is for the circulation of the media and exchanger is for the maintenance of the temperature. The ideal temperature for fermentation is 32 degrees C. Distillation. The fermented liquid with an alcoholic percentage between 7.5% to 8.5% is then fed to boiling column, where alcohol is boiled out and recovered from the top of the boiling column in crude form, while the rest of the material is discharged from the bottom of the column and sent to biogas plant for biomethane production. Crude alcohol is stripped of impurities in the impurities column, from where it is fed to the main distillation column called the rectification column. In this column, pure rectified alcohol is taken at the top, while water, which is free from alcohol, is drained in the bottom or reused for process. The rectified alcohol is further refined in the methanol recovery column and thereafter sent to the daily production tank for storage and further dispatch. Then we have a dehydration unit. Alcohol from the distillation section is further concentrated to 99.9% in the dehydration section. This dehydration process is called as PSA, which is pressure swing adsorption, where the adsorber swings in cycle of adsorption and desorption. The dehydrated alcohol is produced during adsorption step. In the adsorbers, dehydration is done under pressure and regeneration or desorption is done under vacuum. Dehydration is carried out by passing the superheated alcoholic vapors through the zeolite resin, which acts as a molecular sieve, removing the water molecule from the alcohol through adsorption process. Then we have an effluent treatment plant. In an ethanol plant, waste liquid, which is usually termed as spent wash, is fed to biogas plant, where the remaining organic load is converted into biomethane, CH4, in the absence of oxygen. This gas is then used in boilers as primary fuel for steam production. Key benefits of production of biogas are saving of fossil fuel in the boiler, low carbon footprint in environment, low organic discharge for the agri-lands, and it is also a source for biofertilizer. A general composition for this biogas is shown here. The major component is CH4 and carbon dioxide, and then there are traces of some other gases. Now we'll talk about the potential for technical experts. Following are the areas where the technical experts from our local institutions have a lot of potential to implement their skills and the development of this field in Pakistan, improvement in current processes to have enhanced process efficiencies, reduction in sugar losses, new strategies to control bacterial contamination, since hygiene is a very key area of this process. And bacterial contamination is one of the major problem area which affects the overall process efficiencies. Selection of new and more efficient yeast strains, because all the yeast which we are having in Pakistan is imported and there's no local source. So it needs some work to be done. Then technologies for reduction of spent wash volumes and alternative uses by the industry. Conservation of water is also a very significant area for improvement. Development of new fermentation processes for alternative feedstocks and biorefineries for high value added products. Again, Pakistan is an agriculture country, and we have a scope for development of other feedstocks for the production of ethanol in Pakistan. So this is another area for our technical experts to explore. Then we talk about potential for analytical experts. This entire process is very hygiene sensitive, as I have been mentioning already. So it involves a lot of research and analytics for having maximum process efficiencies and consistent product quality. Multiple laboratory tests are involved in the process, such as HPLC for detailed analysis of molasses for its sugar content breakup, then microscopic analysis for yeast culture monitoring, pH testing, acidity testing, Brix testing in the fermentation area. While for the production related analytics, we test alcoholic percent testing through ablumeter, then UV testing through spectrophotometer, moisture content through Carl Fisher operators for anhydrous ethanol, and impurities testing through GLC operators. So there is room for our analytical experts to apply their skills in these areas. If we talk about the exports of ethanol from Pakistan in last 5 years, again here we can see that year 2018 was the year for highest exports, and Pakistan has exported around 6,53,000 metric tons of ethanol, and the last year was with 398,734 metric tons, which is a very handsome source for bringing in the foreign exchange into our national exchequer. If you talk about cumulative exports in last 6 years from Pakistan to different global regions, we can see that Pakistan has exported 8,23,401 metric ton to Korea, and then we can see that there is an export to China and Taiwan, Europe, Far East, Africa, and Gulf. These are the main regions globally where Pakistan has been exporting its product. Pakistan exports in three different forms. One is in bulk shipments, then we export in ISO tanks, and then we export in SGP drums of 250-liter capacity. If we talk about last year's data, Pakistan has exported 239,775 metric ton in bulk shipments, 98,504 metric ton in ISO tanks, and 38,824 metric ton in ISO drums. If you talk about the global ethanol production scenario, we can see that globally last year 130 billion liters of ethanol has been produced, out of which 110 billion liters was produced for the fuel grade sector, which is then applied by blending with gasoline. And 20 billion liters of ethanol is being produced for pharma and beverages sector. This is the overall global ethanol production scenario, and it can be seen that it has a very high and effective application in global in major sectors globally. In the end, I would like to thank you. I would like to thank NAD, IICC, Dr. Saida Nadir Ali and her team for providing us the opportunity to present ourselves at this esteemed event, and we really hope and pray and wish that we can move forward by collaborating between the industry and the academia, because there is we feel that there is a gap between our academia and local industry, and it has benefits for both of us. The industry can benefit from the research and R&D and the analytical expertise of our academia, while the academia sector people can benefit from the industry by applying their researches, by applying their theories in the field, so that we can mutually benefit for our country. And this sector is relatively new in Pakistan, and we feel that there is room for improvement. As I mentioned in my presentation, that Pakistan is an agriculture country, so we really need to research and develop the use of our agriculture waste from different crops, and then we should try to develop the technologies to convert these crops wastages into ethanol and adding more value to our national exchequer. Thank you very much.